Your wife's rollers. Gotcha. Yeah, down there's a big bloopers. It happens. You're gonna have that dice tomorrow in your bag? Yeah, I'm gonna sit on that. It's more comfortable.
There they go.
To the 2010 Northern Arizona University Concrete Canoe presentation. Today, I will be presenting on our canoe, Flying Aces. Presenting with me today are my teammates, Arthur Beckwith, John Culiano, and myself, Dana Wollaston. Northern Arizona University has a strong history of doing well in the Pacific Southwest regional competition. Last year, they placed 4th with Polaris. This year, we decided to dedicate our canoe to UNLV as we're co-hosting the regional competition with them this year. Our project goals this year were to decrease density, have multicolored mixed designs, and use 100% recycled aggregates. Our project management, today I'm going to be talking about project management, analysis, technical design, construction, and results. Project management was identified early on as a key issue for its success. We divided the team members different tasks. I was assigned the project manager, Arthur Beckwith, project secretary, and John Culiano, the project treasurer. The team was divided into further areas, consisting of a construction team, a paddling team, an aesthetics team, and an engineering design team. The engineering design team proved to be the hardest part of this competition. We divided that into further areas. Arthur Beckwith did mixed designs, as well as the hydrostatics. John Culiano did the structural analysis, and I did the reinforcement design. In order to keep project management, we had team meetings, established a budget, and a schedule. The cost of our canoe was $2,700 with 1,700 man hours spent. Project milestones for this was the beginning of the mold, finalization of the mixed design, our pour day, and the conference. For our analysis, we used basic hand calculations. We treated the canoe as a counterlever beam as well as a simply supported beam with an upward distributed load. We used ProLines to develop the waterline to get the proper waterline in the canoe for proper calculations. Strain gauge testing was done to get material properties such as modulus of elasticity and ultimate compression strength. This year we used 100% recycled aggregates consisting of 75% per-hour microspheres and 25% centispheres. We used a fiberglass mesh reinforcement, and it was lined in a stronger weft direction going in the transverse direction of the canoe, as this is where the higher stresses were. Our canoe's properties were 1,000 psi in compression, 848 pounds in braking force, and 48.7 pounds per cubic foot in density. This year in construction, we used a female mold consisting of styrofoam sections. Once the sections were assembled, we sanded it to reduce any high spots and applied joint compound, and then sanded that to reduce any low spots. We had 2 pour days this year, one for the outside layer of the canoe, which was color white, and our inlays, which were a heart, a diamond, a club, and a spade, and they were the colors that they would appear on playing cards. Overall, we feel that this year was a successful year for the NAU concrete canoe team. We used 100% recycled aggregates, had multicolor mixes, reduced our density by over 10 pounds per cubic foot, and almost cut cost in half this year.
So you were the project manager,
Yes.
right? So what was your method for resolving conflict?
Conflict, besides throwing fists, we would sit down, we'd try to sit down together and work it out as a group, you know, although there was definitely some points in time, you know, when we just had to take a day off. Be like, look, take a day off, calm down, we'll relax, when we're all cool-headed, we'll work together on this and get through this together.
Okay.
You were one of the only schools I noticed that did a stability analysis.
Yes.
Any reason?
Well,
If you could change
I
that.
paddled in last year's races. Well, it was fairly easy to get the stability analysis. I got it through ProLines, and I paddled last year. The canoe is very unstable the way it's designed, and this year's shape is very similar to last year's shape.
So what did you do to enhance the stability?
It's just the basic shape of the hull. You really can't do much about it.
Right.
I noticed one of the challenges with hosting was that Lake Mary is potentially frozen this time of year. So do you guys have a place to practice?
We got one practice in.
Did you?
Yeah, I had to cancel one of our practices in because it was frozen and it just wasn't conducive for safety
If
issues.
you look in our executive summary, that last picture is
Yeah.
that our first paddle practice that we had to cancel because Lake Mary was frozen. And he walked up about 3 feet onto the lake.
So what's the problem?
It was like on snow, 3 feet on
Yeah.
the lake in snow,
Right.
and then looked under it and saw that he's on the water, and we're like, we don't want anybody falling in.
Yeah. I got thermia.
In a report, it says that you put, to ensure the proper carrying conditions, buckets of water. Did you actually put the buckets in, or did you pour the water in?
Well, we also had a sheet drenched in water.
Okay, put the buckets, or
And
just,
yes, the buckets were inside the curing tent, and then we had a sheet which we checked every day,
Okay.
and we had it completely wet.
They actually laid, we sat them on the corners.
Okay.
Where they had a lot of styrofoam.
And we had heaters as well. And it was covered in a plastic curing tent.
On that last slide, it says you have 2 poor days. How did that affect the strength of your?
Well, this second pour day was for inlays. They're not a structural element.
Yeah, the first pour day was the structural, the whole canoe itself, and the second was the decorative.
What was the hardest task you guys had to perform on during the life of the project?
Proper project management. You know, just not quitting, but I mean, I'd say that mix table was pretty hard. I know.
Yeah,
John had.
each of us, we broke it out, we helped each other, of course, but each of us had a certain section that we were making sure got done for the project. And so each of us probably faced a couple different issues. Some of it was our mix tables and how we were breaking out our water proportions. Earlier on in our design process for the mixing, we were having trouble with our strength, and we didn't know exactly where we were losing our strength to begin with.
Yeah, what actually happened during one of our mixes, we accidentally left out some of the water, and we decided to properly document it, break it anyway. Then all of a sudden we break it. Whoa, our strength shoots up. We're like, we got to reevaluate. And we went back through our data sheets, and we had incorrect proportions of water.
What was behind the decision to do hand calculations?
Limited resource.
And time.
Yeah, we have 3 team members, and so we were really down to the wire on some of the stuff, trying to get,
You
stay on
had 3
schedule.
total for the whole project?
Yes.
We had help during pour day. With
For construction purposes, but as far as engineering design work,
Just the 3 of you?
Yes.
Wow.
So that, we did work on some analysis, a different analysis, but it just wasn't, we weren't properly prepared with that analysis to back up. And it did back up our hand calculations, so it was a check that we did. We just used it.
And
as a
there's
check.
nothing, I'm just asking what made that, there's nothing wrong with it, just.
and we were fairly conservative in our hand calculations. We did 100 pounds per linear foot per person distributed over 2 feet. So, and treating it also, you know, 2 different ways. One as, you know, basically an upside down, simply supported beam with an upward distributed force, and then another one basically as a 10-foot beam as a counting lever, you know, and we felt that it was a fairly conservative option.
So what was the easiest part of your entire process?
coming here.
Vegas!
Yeah.
Well said, well said.
Don't have to be wordy.
Putting together the display maybe today.